Hi everyone, with this video I wanted to go over the hands-on exercises that we worked on today, and I'm just going to give the solutions that I would come up with. Doesn't mean that they're the only solutions to the problem. Let's start with the first one, where we're trying to calculate the sum of the following list, and here we're just using the random module, and we'll talk about modules next week, and we're sampling 10 numbers from 0 to 99. So you'll see that we get these numbers. Now I'm going to start a new cell so we can have the same list. There's a shortcut function that Python provides called sum, obviously. So we should get the answer 689. The idea of this exercise, though, was to try to see if we could do it in a more basic way. And one way, which is fairly standard in terms of calculating the sum as you're iterating through a sequence, is to set up a number, initialize it to 0, and then iterate. So we write a for loop, we iterate we change the value of the variable val by going over x, and then we are adding and then setting again as s. So we could write this as s plus val, but we can again use a shortcut so we can have s plus equals value, and then we can see what s is, and we're getting 689. So again, it's a fairly standard algorithm of getting the sum from a sequence. Now if we try to get the maximum number of the same list, again, we're trying to sort of iterate, so we would have a for loop, but now instead of summing values, we need to follow a different approach. And when we're thinking about getting the maximum number, essentially we have a number and we compare it with the numbers that we find as we're traversing the list. And if the new number would be larger, then we reset our base variable, the maximum variable, with this new value. So let's do that. Let's have the m being the variable that's going to hold our maximum value. Obviously, because we're looking for a maximum, we need to set this as something very small. And because we know that our values are going to range between 0 and 99, we're going to set it to 0. We could set it to -1, for instance, doesn't matter. But we're bound to find at least the value of 0 as the maximum number. So now we're doing the same thing as before. So we're going for val and x. And this is where things change a bit. So first we want to test for a condition. In this case, we're going to test for a condition of if the new value we find, which is val, is greater than m, then I want you to set m as this new value. And at the end of the loop, we should just get the value of m. And you can use print here or just getting the m value. So now we're getting 97. If we go back, we see that indeed 97 is the largest value. Now there's another again shortcut, and you see how the keyword max became green, font color, oops, not m, of course, max x, because as you saw, m is not iterable because it's a single value, so we got the error, but we get the same answer. Now the other hands-on exercise was asking us to create a list with the numbers between 1000 and 2200 that are divisible with 7 or 5. So the way to approach this is to start out with, and we're going to name it again x, the x variable. We want to create a list of values between 1000 and 2200. If it's inclusive, then we're going to have 2201. Now remember that if we just have range here, we are just going to get the range operator. But in this case, we could create a list, but we don't really have to, depending on how we're going to write the problem. So let's keep it like this. Range 1000 to 2201. Now the new list that's going to have the subset of this, let's name it v. And if we're creating a list, as we're traversing X, we want to be accumulating the elements that satisfy the conditions we have, namely the number being divisible by 7 or 5. So in this case, we're going to create an empty list. And you remember that when we accumulate elements to a list, we can use the command append. So if we now write for, and in this case, let's do val in X, the condition we want to test for is whether the val value is divisible with 7 or 5. Now, if it's divisible with 7 or 5, it means that we shouldn't get any remainder if we do the long division. So the operator that we would use in this case is the percent sign that returns the remainder of that division. So if this is equal to 0, then that satisfies our condition. But then we also have the condition of being divisible with 5. So we can add more conditions by using the keyword or. We could also use the keyword and. And we can do the same thing here. Equals to 0. So then if this is true, then we want you to append the value to v. And here we're going to return v. And there we go. We get a very long list of numbers. Now, if we want to make this a little bit smaller, we see that we can replace this right here in the loop, because we don't really need to define that. We don't need a new variable for this. So hopefully this would make our code cleaner, and we get the same answer. Now, let's go to the next problem of using the print command to print the following pattern. So we're going to create a new cell here. So we've got 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5. Now, one way to do this, if we think about it, is first of all, we want to loop. We want to loop through the different rows, right? So we have 5 rows that we want to loop through. There's a couple of different ways to do this, but the simplest way would be to have a nested loop. So first we iterate over rows, and then we iterate over columns. So let's start out with for row in range 5, because we have 5 rows. Now what we want to do is we want to print out the elements from, if row is, for example, here the first iteration is going to be 0, so we want to print out that value plus 1 and then stop there. All right, so let's do that. So we have print, and now we want to say row plus 1. Now with the second iteration, row would become 1. And now we want to print 2 elements. And here's where we're going to use the second column. Now the problem is that if we do, let's run this for instance, we get lines right away. So we get the new line. So now if we use the command print, we're going to get more lines. So let's try that. So let's do here. Oops. Let's do here. Okay. For column in range. Now the range is going to be, for the first row we need 1 column. For the second row we need 2 columns. So that means that because we're going to start at 0, we need to go from 0 to row plus 1. So let's see here. Okay, here we go. All right. So if we do this, print row plus 1, where you see we get new lines each time. That means that we need something slightly different here. So we need to get the column first of all. So column plus 1, because now you see how this gives us 1, 1, 2, 1, 2, 3. So we have the right sequence of numbers. 1, 2, 3, 4, 1, 2, 3, 4, 5. But now we just need to create lines at the appropriate places. And the way to do this is if we think about the entire row as a string. So if we have a string here, we can do, first of all, we can run the command string, and again we'll get the same thing. But let's try something else. So let's try this variable here, x equals 1, as a string, right? We can say type x string. Remember, with tab completion we can see whether there's any function that we can use to help us, because what we're trying to do in this case is we're trying to join the different strings for each row. Hit the tab again, there we go. Let's see here, find format, index is alpha, blah blah, join. Well, this sounds promising. Let's find out. Well, concatenate any number of strings. So the function here, the input argument, is an iterable. So that could be a list, for instance. So you see here as an example, we have dot, that's the string, and then we join a list. And you see that what it does is it joins this string, and this strings, and in between it will put this delimiter right here. So let's try to do this the same thing here. So what it means is, if we do use this command, we want to create a list. So each time we have a row, we want to create a new list. So let's name it LST and create the empty list. So let's do, for each column, let's see, append LST append, and then we have column plus 1. So let's get rid of this print here. And what we'll do is, for each row, we're gonna print out that LST. Okay, we're getting closer. We got 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5. Great. But we have these brackets here because, again, we're just printing the list. So what we want to do is, if we go to our join command here, we want to join the elements of the list for each row, but with a space as a delimiter. So now we can follow the documentation, and we have join LST. Oops. Okay, let's see what this error is. Sequence item 0, expected string instance int found. So what's happening here is that it's trying to print a list, but what we gave it is an integer. So when did we give it an integer? Let's try again. These are the things you'll be doing. So now we have 1, and this is where it's probably happening, or 1, 2. So let's go back to the error and see what that says, because it should have worked, right? Let's go again. So sequence item 0, expected string instance int integer found. That's because instead of putting a string, we put an integer. And remember that here, as we're going through row and column, the column, which I'm going to comment this out, we're going to just print out, okay, here we go. Let's print out the type of column. See what this is. Integer, there it is. That's what's missing, right? So always pay attention to the error messages that you get from Python. It will be very close to what is the actual problem. So now we just need to convert the integer column into a string. There we go. 1, 1, 2, 1, 2, 3, 4, and 5. So I just took you through this process because it's very valuable to see where things can give us an error. And doesn't mean that our code is entirely incorrect, but it means that there's something very minor that we need to fix. And thankfully Python has very helpful error messages that we can use to investigate why we're getting that error. All right, let's move on and let's find the cumulative sum of the random list we generated, which was the, and I think did I rename it? Yes, I did, unfortunately. So let's just generate it again. And we have range 100, and let's get 10 numbers. There we go. So let's get the cumulative sum. In this case, it's very similar to the sum. But now the cumulative sum, you see that it should have the same length. So if we have a list, we need to get a list back, not a single number. So instead of initializing the sum as 0, we're going to initialize it as an empty list. And we're still going to iterate through our list. But now, instead of just summing to the actual number, what we want to do is we want to append, right? We want to append the value of val, but we want to keep track of what the value from before was. So in this case, what we want to do is we want to have a way to keep the first element, which would be, the first element would be the sum, right? So that would be one way to do it. We can start it with 0, or we can start it with the first element. And then we can, append the value val. But if we do it this way, it's going to be a mess because, again, we don't know what the value was from before. So one easy way to do this would be, again, to have an empty list and actually use the enumeration that we covered today. So we have enumerate, and you'll see why we would need the index, because you can think of, and let's do it this way. So you saw how we can estimate the sum of x, right? Here we go, 595. But remember, we can extract a subset of that array by slicing. So for example, if we go from the start to the second element, we get 73 plus 7, we get 80. So could we potentially do the same thing and extract the sum of the values up to the point we've traversed? And this is where the index comes in, and that's why we have the enumeration. And actually, in this case, we don't even need the value, so we could iterate through the range of the length of x, which in this case is 10. So now the sum would be, for the first iteration, we need to go from just the 0th element. So we need to stop at element 1. So we have x, and then we need to stop here, right? That would be, I would be 0, and then the ending element here would be 1. When I equals 1, this one here needs to be 2. So hopefully you start seeing the pattern, and we have I plus 1. And then what we want to do is we want to append it. And then, there we go. So you see we have the first element 73, then 73 plus 7, 80, 80 plus 86, 166, and so forth. Alright, so the last exercise was counting the number of words with string length of 2 or more and containing the letter A. And with, remember that string is just a sequence of characters, so a list of characters. We could get the length of the word itself. So we have the words here, and what we want to do is we want to go for word in words, and the conditions we want to test is if the length of the word is greater or equal than 2, and the word needs to have contained the letter A. So how do we know whether it contains the letter A? back we go to our tab completion. Maybe there's a function there under S that can tell us what it is. So let's go capitalize case false enter count ends with find. Oh, that might be something, right? Let's look at the documentation for this. S find, return the lowest index in S where substring sub is found. So now we're looking for S. Sorry, we're looking for A, the character A. So if it is found, it's going to give us the lowest index, which means that, because remember, it's a sequence. So if the word starts with A, we should get 0. So let's try it out. That's the character A. We did get 0. Let's try W. We're going to get 2 because it's 0, 1, 2. That means that the word, we can run find and then A, and we need to make sure that this is greater or equal than 0. So if that's the case, we need to add the word to our counter. And the way to get a counter is we could either create a list and just add the word if it satisfies those conditions, but it would be easier because we're only interested in the number of words. We have a counter, we set it to 0, and in this case here, we just add 1. And on this, we get 3 words. 1, 2, 3. Hopefully this covers everything. Again, if you have any questions, please feel free to reach out.